This video we're going to be talking about composition of functions. Composition of function, which can be denoted as f open dot g, is defined by f of g of x, where essentially what we're doing is we're taking the g of x function and we're plugging it in for x into the f of x function. Now there's some weird things with domain and range depending on the types of functions that you're using. The domain of the composition is a set of all domain values of g whose range are within the domain of f. So if g's domain is restricted, then that will restrict the overall domain of the composition. And if f's domain is restricted, then that will also further restrict the domain of the overall composition based on what y values or range values g can output. So depending on the types of functions that you have, depends on how the restrictions come about and intermingle. It can be sometimes tricky to find the actual restrictions depending on those types of functions. Okay, in this example, we're going to find the composition of f with g. This open dot represents the composition of the two functions. We have our f of x function and our g of x function here. So the composition of f with g simply means that we're going to take our g of x and we're going to place it inside of our f of x. That's what that means. So when you're first setting it up, it can be a little confusing. So my recommendation is to go through the outside function and just put parentheses wherever you see an x. So we have 2x minus 1. So I'm going to go through the outside function and put 2 instead of an x. I'll put a set of parentheses, then minus 1. So you notice the x is now parentheses, and then we can fill it in. We're going to fill it in with x plus 1 over 2. So that's the setup. Once you have it set up, you just have to simplify the expression. Normally, we would try to distribute the 2 on the outside through. However, there's only one term, and on that one term, there is a 2 on the bottom of the fraction, so the 2's will cancel out, leaving us with x plus 1. My minus 1 coming down. Then if I combine like terms, it'll cancel out, leaving me with x. So the composition of f with g is just equal to x. Now this is actually very important for one of the future lessons, so just keep that in mind. It's a rare circumstance whenever x comes out to be the answer, and that has a important meaning when we talk about inverses. Okay, in this example, we're asked to find the composition of f with g with the function x squared plus 2x plus 2 and the function g of x equals 4 minus x. Now, finding the composition of f with g means we're finding f of g of x. Where f of x, I'm just going to kind of color code my setup with f of x being my blue one and g of x being my green one. Now, when you're first learning it, I find it really helpful if you go through the outside function and put parentheses anywhere you see an x. So if I go through my outside function, which is f, it says x squared, so I'm going to put parentheses squared. Then it goes on to say plus 2x, so plus 2x, but instead of x, I need to put my parentheses. And then it goes on to say plus 2. Then inside the parentheses, I need to put my g of x function, which is 4 minus x. So that's the setup for this f of g of x, this composite function. After that, we just need to go through and simplify. So starting with exponents, we'll deal with the 4 minus x in parentheses squared. Now there is a formula for perfect squares, but I do know it can be sometimes hard to remember. So if you can't remember the formula to distribute a perfect square trinomial, we can always write it out twice and distribute it by hand. This is also always an acceptable way of doing it. It's not as quick as using the formula, but it still works. And it's better to know where the formula comes from in the first place rather than just rely on the formula. If I combine like terms, we get 16 minus 8. If I can get my hands to write what I want to write them. Minus 8x plus x squared from simplifying the 4 minus x in parentheses squared, whether you use the formula or whether you distribute it by hand. The second portion here, this multiplication, going through and distribute, we'll have 2 times 4 is 8, and then 2 times negative x is negative 2x. And lastly, that plus 2 is just going to come down. Now it's just a matter of combining like terms, because it looks like we have no more multiplication that we can do. So just starting with our highest power, our x squared. There's no other x squareds, so I'm just going to throw them first. We have a negative 8x and a negative 2x, which will make negative 10x. We got our 16 plus 8 is 24, plus another 2 is 26. So overall, we have x squared minus 10x plus 26. There we go. Okay, in this example, we're going to find the composition of f with g. If f of x is 2x squared plus 5, and g of x is the square root of the difference of x and 3. Now, just like the other examples, we'll start by going through our outside one, doing the composition, f with g. So we're going to start by going through the outside function and put parentheses where I see x. So I have 2x squared, so 2 parentheses squared plus 5. Then my inner function is going to be my g of x, which is the square root of x minus 3. So here is the initial setup. If I go through and simplify, squaring the square root will cancel out. Give me 2 times, I still need the parentheses because of the 2 separate terms. So 2 times in parentheses are x minus 3, which I wrote another x, there we go. And then we have the plus 5 outside. Continue simplifying, we'll distribute and then combine like terms. So 2x minus 6 plus 5. Combine like terms, we have 2x minus 1. So we're going to go ahead and go to Desmos because while we did find this expression, we do have an issue with this problem. So here, if I get rid of the thing that I typed the wrong equation for, there we go. So I have everything graphed here. I have the original function in red, in green, or red and blue, graphed. Those are the 2 original functions that we have. And the purple is what we got when we combined the 2. So here's our purple, here's our blue for our g of x, and here's our red for f of x. But if I actually make the composition visible, we'll see something doesn't match up. So making the composition visible, you can see that the green, which is the composition, starts here and only goes this way. Well, there is an issue, and I just accidentally closed the graph, it looks like. Oh no, there it is. Okay, there's an issue because the square root function doesn't actually exist to the left of x equals 3. It starts there. And because one of the functions that makes up the composition doesn't exist to the left of 3, then our composition can't exist there either. So, when it comes to this, since this is the inner function, this will determine the x values that can be plugged in. We are limited to just being able to use x values greater than or equal to 3. as part of the composition. So our answer consists of both the expression part and this restricted domain for the resulting composition. Because for f of x, we could have used any x value, but g of x, we were limited